My name is Nick Brzezinski. That's me on the left in the picture there. My fiance and I just got back from Gatlinburg. Great place to visit if you guys are looking for a vacation destination. But I'm with D3 Technologies, and I am a solution specialist for the CAM software. So today, our agenda, we're going to do the introduction, go through a demo of what's new. I got very little PowerPoint here, and most of it's going to be hands-on, showing you guys the software. And then at the end, we'll go ahead and answer any questions that you guys might have. And this is being recorded, so if anyone has or is not able to join, we will go ahead and email that out to everyone who registered for the webinar. So if you guys have questions during the presentation relevant to the topic I'm on, you can go ahead and shout that out at the time inside the questions dialog box there. We have Aaron Lancaster with D3 also on here, and he's going to keep an eye on that chat log and intervene if we have any questions. So first thing I want to talk about is our development page for the CAM software. So let me switch over to my web browser. And if you guys go to cam.autodesk.com, here you will see it was just put up here that we now have the download for Inventor HSM 2017. If you go to products up here, you can go down to downloads. And within here, we have all the downloads for the different products. So we have HSM Express, HSM Works, all those downloads are listed in here. And actually, while we're on that topic, let's go ahead and do a quick poll. Asking about if you guys are currently using any of the HSM products. So we'll do a few seconds here. Okay, so it looks like we have mostly Express users. So within here, you'll see there is the Express download. The full version, if you click on Inventor HSM or Inventor HSM Pro, within here you will see they have updated to the newest build version. So we now have the 2017 version up there for download. And the other thing I want to point out is at the very bottom here, you'll also see our development versions. So if you're not familiar with the way the development is going with the software now, we're no longer waiting for releases at the end of the year, every year, to give out the new features. The development team is putting these up here on this development page, and you can see here May 3rd, and going back, you can see all the stuff that's been added over the last year to the software. So this is great for users. They're getting good value out of their money spent on the software. You get new tools throughout the year, and you can go in there and keep it on that page and download those as they come out. So a lot of the stuff is going to come from our development versions here into the 2017 version. And for those of you who are Express users, you can go in there and also, I think it's on your ribbon, you should see a 30-day trial to try the full version if you want to see or try out these new tools. And then also, for those of you who have purchased, it should also show up inside your Manage account. So if you go to manage.autodesk.com and log in, you should see all the products that you have purchased. So there's Inventor HSM. I'm not going to click on it because it has my serial numbers on there, but if you click on this and download, it'll show you your serial number, and you can download the products from there as well. So I'll get back to the presentation. Minimize this. There we go. Okay, so engraving and component patterning, two of the new features in 2017 that really should help with productivity. Let's jump into the software here. So here I have a tombstone set up with a couple parts on one side and some different parts on the other side. And then you can see it's patterned around that tombstone. So one of the really nice features that we've added, so in the past we've always had pattern, but in the past it was limited to linear, circular, and mirror. What they've added in 2017 is the component and duplication patterns. So the way to do this, you select your setup. So we have one setup here. Which side's it on? There it is. So you can see we have this one part programmed. So we got all these operations in here. If you highlight by holding Shift and select all of those, You can then right-click or go up here and click Pattern, but right-click, Add to New Pattern. And here we're just going to select Component. So as long as you have everything laid out the way you want it to be set up in your machine, you can just select the source. The software's smart enough, intelligent enough to go in and find all those other parts that have been placed into the assembly here. So I don't even have to select the targets. I've got the automatic button checked. You can see it added toolpaths for all those other components. And I also want to point out, we also have the ability to change the way that those are posted out. So we can preserve by order, operation, or tool. So if we go by tool here and simulate that pattern, you will notice, so we're coming through with that face mill or end mill, and it's going to face off all these parts of the same tool before it switches to the next tool. So we're maximizing the efficiency of our tool changes here by doing this. So nice feature there. Next one was engraving. So you can see we actually have a part number engraved onto this part here. If I just right-click and open that up, we can see that I have within the model, there's an extrusion here based off of a sketch. So you can use extrusions, cut extrusions, or if you're familiar with the emboss, you can use that to cut and emboss as well with your text. So all we have is a simple text box here, and you'll notice if I go into that text box, we're using the Georgia font. So I'm going to jump back into the CAM, what I call the CAM browser over here on the left side. So we go between model and CAM. And within that setup that I already have created, and you can see we have the WCS positioned off of that hole. Within here, I'm going to come in, and this is one of the new features, is the engrave. And what this allows us to do is we can come in and select a chamfer mill and go to the counter selections and just select the edges of that contour that was created. And so by doing this, it works with any font that you might have, or maybe even some type of artwork or something that you may engrave into the top of a part, because you can see you have varying width throughout that sketch. So what it's going to do, if I hit OK here, is it creates that toolpath, and based off of the width of the extrusion, the tool will vary in Z heights to account for that, so that the sides of that chamfer are always in contact with the edges of the font. So if we go in and simulate that, you can see that that height is varying for that to account for the width of the font as it's going through. So this is very versatile as far as what you want to engrave. In fact, if you want to go through, maybe your customer has a certain font that they want, or you maybe want to change different things, you can go back and jump back and forth between a model and just edit that sketch. So maybe I wanted to make that Times New Roman. Go through and edit that, finish the sketch, go back into the CAM environment. You get the red X there telling us that something has changed. You can see it's a little bit off here. All we're going to do is regenerate that toolpath to the new font. Looks like a couple of them jumped off there. We'll just reselect those. And then we have our new engrave. So great way to do it. There's also, for those of you who just maybe want to do a single stroke font, you can contact me after this, and we have an engraved text feature that one of the forum members has created. And within there, you can actually create a single line text font and just trace that along as well. So way to do that, obviously you need a sketch as it was telling me there, so I'll just create a new sketch in this face, go to engrave text, we'll just use that part number there. 5 millimeters tall, and then place it. Now you could rotate it and do everything there, but what that did was created a single line sketch that you can then use the trace tool to just come through and trace that single line text. So contact me if you want to get your hands on that, and I'll send you the link for it. The next thing is 2D chamfer and AnyCAD. So AnyCAD was introduced in 2016 version. They have made some improvements to it on 2017. What I'm going to do here is go to Open, and within my Cycles tab here. So right now I'm on All Files, which is looking for all Inventor files. So you only see those. If I change this to all, well, I thought that's where I placed it. Let me finish the sketch first. Oh, I know where I put it. My mistake. It's in the what's new 2017. There we go. So here we have a couple SolidWorks part files. So if you guys are ever getting non-native Inventor files from your customers, we now have the ability to actually portal in to that part file and open it up with inside the Inventor software. So if I hit open here, it's asking me, do I want to convert it, which we've always been able to do, which converts it to basically a dumb solid as a Inventor IPT file. What's new is this reference model. So if I hit OK, you can see it opens it up, and we get this little symbol over here telling me that this comes from, it's a link, which is referencing or porting into that exact SolidWorks part file. What this means for us is if we go in and do something like the 2D chamfering, let's go in and just find a chamfer tool. First, let's do a setup. So orient my Z, place my G54, say OK. Let's go in and do a 2D chamfer. I got my 1/4 inch 45 tool, and then it's looking for contour selections. I'm kind of tying two things together here, but this 2D chamfer, you go through and select edges, and this allows you to go in and deburr your parts. Maybe we just want to go in like 10 thousandths with a 10 thousandths clearance. So the software is smart enough to realize the geometry of that chamfer tool, and it's going to remove what it can, avoiding all these islands or bosses that stick up off the edge. So if I say OK here, you can see where the tool path trims itself, comes off, and starts back up again over here because that tool would have collided with this boss. Same over here. It doesn't go all the way to the corner of the edge. It recognizes that we would have a collision there and starts off the edge. So if I simulate this, you can see we're into the part 10 thousandths. And it avoids that island. It's a great way to, and you can see right there, it just kept that 10 thousandths clearance between there. But this will really save you a lot of time from having to go through and deburr your edges. You can go through and do it while it's set up in the machine after you get done milling out all your pockets in different geometry. So with that, in AnyCAD, let's say your customer decides, halfway or right before you machine the part that he's going to change some things on the model. We are porting into this part file. So let's look at the Explorer, Windows Explorer here. I have the chamfer and chamfer_1. So chamfer_1, let's say that that's the new part that your customer sends to you. If I go in here and maybe rename the original, the one we have open, to _old, and then change my chamfer_1 here to the original name. So this is the new one the customer sent you. You just place it with the same name in the location that the original file was in. As soon as I hit enter here, you'll notice up here in the top corner that we're going to get an update. So there's that update. Because the file has changed, it's recognized that immediately that we changed the file that we're referencing. So as soon as I hit OK, keep your eye on this pocket here, and it updates the changes to that new model. So here we've changed the depth, the width, and the angle of that pocket. And so with that update, you also get a red X over here. The software is smart enough in telling us right here that that toolpath is no longer represented by the model. So you can see what it used to be. So we just need to right-click, generate that toolpath, and it comes through and now updates to that new geometry in the model. So this is great for, and even this works off of step files now. So that's a new introduction to AnyCAD for 2017. Is if you're getting step files from your customers, you can actually open that up and reference the step file. If your customer sends you a new step file, you just place it in the same location with the same name, and all your toolpaths will then update to that new step file. So great for the job shop community working with the HSM software. So one of the big ones that's been added in 2017 here is probing as well. And I have another quick poll for you guys. See if any of you guys are using probing. Let's go ahead and launch that. Okay. Looks like we don't have any on here, but what probing is going to do, close that. Previous. Jump into software here. So here I have a bearing block part within a vise. We've got two different setups here. So what the probing allows us to do is take our Renishaw probe, for example. It can come down and touch off this part and figure out where it's located and automatically update our work offset inside of the CNC mill. So here we have on this job a facing operation and a contour operation to cut off these corners. If I go through and add a WCS probe, again, we got the tool library, so we're going to come in here and I've got a Renishaw probe. I select that. Geometry tab is looking for probe surfaces. So anytime you select a plane in the Z or XY plane, it's going to do a probe Z surface. So it's going to come down and touch that surface off. If we do two opposing faces, it's going to find the midpoint of those, and that's going to give us our X wall. So let's say we're going to probe the X for this part, and then maybe do another one to probe the Y. So I'm going to select the front face and the back face. It's going to find the center of those two. So after we load the stock in here, it's going to come through, find the center of the X of the block, and find the center of the Y for the block. And you can see over here it added two probing operations into the software. I want to do that before I start my operation, so I'm going to drag those up above. And then the other thing I want to point out is if we go into the job setup, they've made changes here as well. So on the post-process tab, we now have a WCS offset which we've always had, but they've added this probe WCS override. So what this is saying here is our WCS offset 1, which is equal to G54, is what it's going to be using. But for the probing, we're going to use G55. So I've got 2 there. So if we go ahead and post this out, I've got the Haas generic post processor, hit post. We can see what it's doing here. So we got our normal startup code, and then right here we see under probe G55. So it's going to probe that X, probe the Y, and then down here it's going to use G54 when we start facing. So the probe is working off of G55, it updates that inside the mill, and then sends that to your G54. So how it's doing that, you can see here this P9832. If we are to look at, for instance, the Renishaw programming manual, so you can see 9832, that's a macro. So it's turning the probe on, 09 or 9832, that's a macro. So these are loaded into your mill. It sees that inside the code, starts it, and then it's going to go down and touch those sides off and then update that inside your mill as well. It's a great way for locating parts. You can use it to locate holes. It's great for subsequent setups. So when you go to the second setup, you can touch off different features there and find out exactly where that is once you load it into your vise. So great addition to the 2017. Jump back here. Another operation they've added is 3D Morph. So here I have a part. So in the past, we've only been limited to, you could do like a spiral or a scallop on this. But if you wanted to run the tool along the contours of, for instance, a slot like this, we can now do new operation, 3D milling, morphing. I'm going to select my ball mill here. And what it's looking for is curve selections. So if I select, and here's a tip for you, if you need to do a single edge selection, you can hold down the Alt key. It'll find a single edge, as opposed to not holding down the Alt key, it finds the entire contoured loop along that surface. So I'm going to hold down the Alt key, select that contour, and do the same thing for that contour. And you can see we have arrows both pointing in the same direction. And on the passive tab, you then have your step over. So I'll say OK here, and it's going to morph that toolpath from one side to the other. Let's get in there. To machine or finish machine that surface. Where this is really nice is, let's jump back into the model of this part. And let's say our morph goes like this, where we aren't going from the same selection. So we're now going from a straight edge to a curved selection. And you see the red X layer represented by the model change. So I'm going to edit that. And let's just select one edge now to go from the straight line to the curved selection. Here you can see it's morphing that straight edge over to a curved edge. So you can see there's going to be a variation inside the step over, where it is over here versus where it is over here. So what's really nice about this, if we go in and edit that again, we can actually add more contour selections. So let's say we want to go from this straight edge to this one. That'll morph those two together. And then from that edge to this edge, that'll morph those two together. So we're able to do multiple selections. And what this does is now, instead of having that variant step over, we now have a separate morph for this curved area versus the one for this flat area where it's gone from curved to a straight edge. So pretty versatile as far as making multiple selections inside of that morphing strategy. And we got about 3 minutes to go. So we've got pull-away shaft and holder. That was also added to adaptive clearing and a few other strategies. Stock to leave is now available for the turning operations. Chip thinning, kind of a neat feature that we've added for facing operations. For instance, if we take a look at this one, it is on the passive tab. There's now a use chip thinning. So instead of running the end mill straight into the part, it's now going to roll into the corners. So if you simulate that out, I'll turn the stock on here. You can see it rolls into that corner on both sides. Actually, it's probably easier to see without the tool turned on. So you can see there it rolls in as it's starting out. So that helps preserve those inserts on your face mills. And then the last thing I wanted to touch on was beta mode. A lot of people aren't familiar with this, but there is a beta mode built into the software when you install it. If you have a CAM operation open and you hold down the shift and control buttons and right click, you can then go down to beta mode. Once you select that, here's one of the new features immediately that you can see is we now have an end of, kind of like an end of part marker in the model, but this will automatically update where it's going to add the next operation that you add. So it's going to go just above that line. The other neat thing that they are working on in the tool library is we have a few new mill tools, or a few additions to it. So if we go to the cutter tab and go to a tapered mill, we now have the ability to change between bull nose and ball nose tapered mill. So that was added in there. On the mill, we now have the ability to add a taper angle. So if you have a face mill with 45-degree inserts, you can go ahead and add that on there as well. And then the last thing here is they've added a thread mill tool. So if you're doing any thread milling with a multi-point thread mill, you can go in and create that tool as well, and then go ahead and use your circular 2D milling operation to add that thread milling operation.